students. Today I am going to start your next chapter, and your next chapter is force and pressure. In this chapter we will study about the first of all turning force, then moment of force, pressure exerted by liquids, pressure exerted by gases, effect of pressure on the volume of a gas, compressed and expansion of gases, compression and expansion of gases, then measurement of atmospheric pressure. And today we will discuss about the two topics, that is turning force and moment of force. Your first topic is turning force. What is your turning force? Consider this is your object, and we apply a force F on this object. This is the applied force on an object. Due to this force there is a motion, and this motion is a linear motion. In second case, if we apply a force on a door, this is your door, and we apply a force on a door, in that case there is a turn, means circular motion is there, or after applying a force there is a turning effect, turn is there. In both the cases effect of force is different. In this case, if we apply a force on a body, then there is a linear motion, but if we apply a force on a door, then there is a circular motion or turning effect is there, and body turn about a fixed axis. This is your fixed axis and this is your door, and door rotate about this axis. That is, there is a motion about a fixed axis or a turning effect is there. Such type of forces which give a turning effect or rotate the body about a fixed axis, that forces is known as turning force. There are different examples are there. If due to effect of this force there is a linear motion, but if we apply a force on a door, then the turning effect is there and door rotate about a fixed point or about a fixed axis. The force which can rotate a body about a axis passing through a fixed point is called turning force. For example, force applied on the handle of a door. If we apply a force on the handle of door, then door rotate about a fixed axis of a door which is fixed at a hinge, turn or rotate the door around it. Second, a spanner used to tighten a nut. Third example, seesaw. These are the example. If we apply a force, then there is a turning effect. If we apply a force on a nut, there is a turning effect, there is a rotation, and this rotation about a fixed point or about a fixed axis, and this particular point at which body turn, that point is pivot. What is the pivot? The central point on which something turn or balance. This is your pivot, because at this point nut turn and nut turn due to application of this force. Therefore, after applying a force, turning effect is there, and this force produce turning effect, and such type of forces is known as the turning force. Now it is clear about what is your turning force when we apply the force and turn is there. Your next is, what is the turning effect? Moment of force. Next is, what is your moment of force? Let's start with example. This is your body and we apply a force perpendicular to a body. This is your applied force, and this is the axis of rotation. This is the axis of rotation. This body move around this axis. This point is fixed. It means body rotate about a fixed axis. Now what is the moment of force? Moment of force is the force, product of force. Moment of force is equal to product of force and perpendicular distance from axis of rotation. This is your axis of rotation and this is the perpendicular distance from axis of rotation. Why we use the word perpendicular? Because this distance is perpendicular to the applied force. This distance is perpendicular to applied force. So what is your moment of force? Moment of force, that is equal to product of force with perpendicular distance. This is your perpendicular distance from axis of rotation, and moment of force is known as torque. Now your next physical quantity, that is, we can say that your moment of force also known as torque, and what is the moment of force or torque? That is the turning effect. When we apply a force and there is a turning effect about a fixed axis, in that case moment of force is equal to product of force into perpendicular distance and perpendicular distance from the axis of rotation. So your formula is moment of force or torque. Moment of force or torque is equal to force into perpendicular distance, or in another words, we can also define torque or moment of force as a turning effect about a fixed axis. To define torque, what is torque? What is the moment of force? Moment of force or torque is a turning effect. And what is the mathematical formula of turning effect or torque? Torque is equal to force into perpendicular distance. Now next is, this torque is a vector quantity. And vector quantities are those quantities which has magnitude as well as direction. Now what is the magnitude of torque? And what is the direction of torque? Torque is a vector quantity and vector quantities are those quantities which has magnitude as well as direction. Now next question is, what is the magnitude of torque? Magnitude of torque is force into perpendicular distance. This is the magnitude of force, perpendicular distance from axis of rotation. In this case, this is the perpendicular distance because force is perpendicular to this distance. Now what is the direction? Direction of torque is perpendicular to distance and force. Direction of torque is perpendicular to distance and force. The direction of torque is perpendicular to distance from axis of rotation and force. Distance from axis of rotation and force. So this is your direction of torque. This is the direction of torque and this direction is perpendicular to distance and force. Now what is the moment of force? Turning effect is known as moment of force. What is the torque? Turning effect is the torque, and torque is the vector quantity. What is the magnitude of, and vector quantity has both magnitude and direction, and magnitude of torque is force into perpendicular distance, and perpendicular distance, that is distance from axis of rotation from the point at which we apply a force. And what is the direction? Direction of torque is perpendicular to force and distance. Now next is, what is the line of action? If we apply a force, this is your applied force, then this is the line of action. This is the line of action along which we apply a force. If force, this is the direction of force, what is the line of action? This is the line of action. If this is a force, what is the line of action? This is your force. What is the line of action? This is the line of action of force. Now this is the applied force, and for this force, this is the line of action. Now torque is equal to force into perpendicular distance of line of action from the axis of rotation. What is this perpendicular distance? Perpendicular distance is the distance between axis of rotation and line of action of force. We consider another example. For example, this is your door. This is your door. And when we apply a force, we apply a force in this direction. Turning effect is there. Door turn about a fixed axis. This is your fixed axis. This is your fixed axis. So there is a rotation about a fixed axis. So what is your torque? Torque is the force, product of force and perpendicular distance. Perpendicular distance of axis of rotation from line of action of force. This is your perpendicular distance. Next is, this is your torque. The turning effect of force is called moment of force or torque. Moment of force about a pivot, about a point, about that is axis of rotation, is the product of force and perpendicular distance from the line of action of the force. Therefore, moment of force is equal to force into perpendicular distance of line of action of force from the axis of rotation. SI unit is, what is the SI unit of torque or moment of force? Unit of force is Newton and unit of distance is meter. So therefore, SI unit of moment of force, or we can say that SI unit of torque is Newton meter, because this is the product of force and perpendicular distance. Next is, this is your example. This is your applied force and this is the perpendicular distance, because in this case this applied force is perpendicular to the distance, perpendicular to this line of action and axis of rotation. This is the axis of rotation. Moment of force about any point is defined as moment of force is equal to force into perpendicular distance, and unit is Newton into meter. Moment can either clockwise or anti-clockwise. This slide from your book. The turning effect of force, the turning effect of a force acting on a body about an axis passes through a fixed point is called moment of force. This is your keyword, turning effect. Moment of force is a vector quantity. They have magnitude and direction. Direction is perpendicular to force and distance. Moment of force is equal to product of magnitude of force and perpendicular distance of line of action of the force from the axis of rotation. So what is your perpendicular distance? This is your, if this is your axis of rotation, If this is your axis of rotation and this is your applied force, then this is the line of action. Now draw a perpendicular on the line of action. This is your perpendicular distance. Next is numerical problem. The door of building is 1 meter wide, means width of door is 1 meter. Width of door is 1 meter. It can be opened by applying a force 10 Newton at the middle. We apply a force at the middle and force required 10 Newton. Calculate the least force which can be opened the door. What is the least force? Find the moment of force or torque. What is the moment of force or torque? Moment of force is equal to force into perpendicular distance. Moment of force is equal to force into perpendicular distance. Therefore, in this case, moment of force or torque is equal to, this is your torque. Torque is equal to force into perpendicular distance. This is your perpendicular distance. So what is the force? Force is 10 Newton. What is the perpendicular distance? This total distance is 1 meter and we apply a force at the middle. At the middle means this distance is 1 by 2 meter. This distance is 1 by 2 meter. That is, distance is 1 by 2 meter. So your torque is equal to force into perpendicular distance. Applied force is 10 Newton and we apply a force at the middle. Therefore, distance is 1 by 2 meter because total is 1 meter. And moment of force in this case, moment of force is 10 into 1 by 2 meter, that is 5 Newton meter. This is your moment of force or torque. And now we want to determine minimum force required to open the door, to turn the door. If we apply a force at the edge, in that case this distance is 1 meter. In that case this distance is 1 meter. Find the force. If we apply a force at the edge, this is your door. If we apply a force here, this is your force. This distance is 1 meter and torque is 5 Newton meter. Find the force. What is the minimum force required to produce the same torque or same turn? We apply a force at the edge here, and this at distance of this point from axis of rotation, that is 1 meter. This distance is 1 meter and moment of force, that is 5 Newton meter. So what torque is equal to, this is your torque and this is your torque. Torque is equal to force into perpendicular distance. Find the minimum force. What the torque? Torque is 5 Newton meter. Force as it. Find the force. What is the perpendicular distance? Perpendicular distance is 1 meter. Therefore 5 is equal to F into 1 meter, that is F. Therefore minimum force is 5 Newton. Minimum force required to turn this door is 5 Newton. Now there is very important term, that is, this is your door. When we apply a force at the center, then force required is 10 Newton to produce the turn. When we apply a force at the end, required force is 5 Newton. This is your answer. It means if we apply a force at the edge, in such case we require less force to produce the same turn. That's why handles are provided at the edge of door. because when we apply a force at the edge of door, we required less force to produce the same turn, and if we move towards the axis, we required greater force. Now perform a simple experiment. First apply the force at the edge and then apply force at this point near the axis of rotation. You find that we need greater force to open the door or close the door if we apply a force at this point, and we need less force to open the door or close the door if we apply a force at this point. This is your numerical, and if you perform this experiment at home, you will definitely get the answer. If we apply a force at the edge, then we require very small force, and if we want to open the door or close the door by applying the force near the axis of rotation, in that case we need greater force. And this is your numerical. If we apply a force at the center, we need 10 Newton force to produce the turn, to produce the torque, and we need 5 Newton force if we apply a force at the edge of door. Now what is your question? The door of a building is 1 meter wide. It can be opened by applying a force 10 Newton at the middle. If we apply a force 10 Newton at the middle, then we open the door. Calculate the least force which can open the door. First of all, we determine the torque. Torque is 5 Newton meter, and by using this torque we determine the minimum force, and we consider that if we apply a force at the edge, at the open end, at the edge, in such a case the force required is 5 Newton, because your torque is equal to force into perpendicular distance. Force into perpendicular distance is equal to torque. Force is F, perpendicular distance is 1 meter because 1 meter wide, and torque is 5 Newton meter. Therefore force is equal to 5 Newton meter upon 1 meter. There is cancellation of unit of meter, and force is 5 Newton. Thus force of 5 Newton is the least force required to open the door, and this is the reason why we provide handle near the open end, because if we apply a force at the open end, we need less force to open the door and close the door. Thank you, students.